So here we have a function phi of 3 variable given by logarithm of x cubed plus y cubed plus z cubed minus 3xy z. Now we need to find out the value of this particular expression. So let's begin. So let's start with whatever we are provided with. So here we are given that the phi, which is a function of x, y, z, is log of x cubed plus y cubed plus z cubed minus 3x y, z. Let's label this as equation number 1. Now what we'll do, we'll take the partial derivative of phi with respect to x. So we'll also have to take the partial derivative with respect to x of log of x cubed plus y cubed plus z cubed minus 3x y, z. Now we know that the partial derivative of the logarithmic function, so that means if we have ddx of log x, so that value is simply equals to 1 over x. So using this fact, we have 1 over x cubed plus y cubed plus z cubed minus 3xy, z multiply to derivative with respect to x of x cubed plus y cubed plus z cubed minus 3xy, z. So here we are using the chain rule. So this will give us multiplied to the partial derivative with respect to x of each of the terms within the parentheses, the partial of x cubed with respect to x plus partial with respect to x of y cubed plus partial with respect to x of z cubed minus partial with respect to x of 3 times x y z. Let's find it out. So this gives us now partial of x cubed with respect to x, so that will be 3x squared. Partial of y cubed with respect to x, that will be simply 0 because y will be treated as a constant with respect to x. Similarly, partial of z cubed will be 0. And for the fourth term, we have 3y and z, these are constants. So 3y times z multiplied to partial of x with respect to x, which is simply 1. So that means we get partial of our function phi with respect to x as given by 3x squared minus 3yz divided by x cubed plus y cubed plus z cubed minus 3xyz. This be equation number 2. Now similar fashion, if we start off with again equation number 1, that means phi equals to log of x cubed plus y cubed plus z cubed minus 3xyz, and we take its partial derivative with respect to y, then follow the same steps and we should get 3y squared minus 3z times x divided by x cubed plus y cubed plus z cubed minus of 3xyz. So this will be equation number 3. And we can again take equation number 1 and take its partial derivative with respect to z, which will give us 3 times z squared minus 3xy divided by x cubed plus y cubed plus z cubed minus of 3xy times z. So let this be equation number 4. Now what we'll do, we'll add equation 2, 3 and 4, and this should give us partial of phi with respect to x plus partial of phi with respect to y plus partial of phi with respect to z. So this will be equals to, so we have a common denominator in each of the 3 cases. So we will add up the numerator to get 3x squared minus 3yz plus 3y squared minus 3zx minus a positive 3z squared minus 3xy all divided by x cubed plus y cubed plus z cubed minus of 3xyz. This now gives us partial of phi with respect to x plus partial of phi with respect to y plus partial of phi with respect to z. In the numerator, we'll take 3 as the common factor. So this gives us x squared plus y squared plus z squared minus xy minus yz minus zx whole divided by, so here we have x cubed plus y cubed plus z cubed minus 3xyz. This can be also expressed as x plus y plus z multiplied to x squared plus y squared plus z squared minus xy minus yz minus zx. Now the term from the numerator and from the denominator gets cancelled, and it leaves us with 3 over x plus y plus z. So this is partial of I with respect to x plus partial of I with respect to y plus partial of I with respect to z. So let this be equation number 5. Now finally, what we'll do, we'll take partial with respect to x plus partial with respect to y plus partial with respect to z, and this will be operated on partial of I with respect to x plus partial of I with respect to y plus partial of I with respect to z. So we'll apply this partial derivative to the right hand side as well. So we have partial with respect to x plus partial with respect to y plus partial with respect to z of 3 divided by x plus y plus z. So this actually means partial with respect to x plus partial with respect to y plus partial with respect to z. So this is operated on this function. So here we can also rewrite this as partial with respect to x plus partial with respect to y plus partial with respect to z operating on the function phi. So this will be equals to, now we'll apply the partial derivative of x on this particular function. Similarly, we'll apply partial derivative of y on the function and partial derivative of z on the function. That means we will have partial with respect to x operating on 3 over x plus y plus z plus partial with respect to y operating on 3 divided by x plus y plus z plus partial with respect to z operating on 3 divided by x plus y plus z. Right. Now this can be combined to give us partial with respect to x plus partial with respect to y plus partial with respect to z squared. So this is operating on the function phi, which will be equals to, now we'll have to apply the partial derivative with respect to x on 3 over x plus y plus z. So this can be also expressed as 3 times, so here 3 is a constant, so we have partial with respect to x multiplied to x plus y plus z raised to the power of -1 plus 3 times partial with respect to y of x plus y plus z raised to the power of -1 plus 3 times partial with respect to z of x plus y plus z raised to the power of -1. That will be equals to, so we'll have to apply the power rule. So we have 3 times -1 multiplied to x plus y plus z raised to the power of -1 minus 1. Then we'll apply the chain rule to the expression within the parentheses. We'll have partial with respect to x of x plus y plus z. For the second term, we have 3 times -1 multiplied to x plus y plus z raised to the power of -1 minus 1 times partial with respect to y applied to x plus y plus z plus 3 times -1 multiplied to x plus y plus z raised to the power of -1 minus 1 times partial with respect to z applying on x plus y plus z. Thus we have -3 divided by x plus y plus z raised to the power of 2. So here we have brought this expression to the denominator times, so we have partial with respect partial of x with respect to x plus partial of y with respect to x plus partial of z with respect to x. So this will be equals to 1 because y and z will be considered as a constant when we're taking its partial derivative with respect to x. For the second term, we have -3 divided by x plus y plus z whole raised to the power of 2 multiplied to 1, because partial of x plus y plus z with respect to y will be 1. Here x and z will be considered as a constant, minus the third term, which will be 3 over x plus y plus z whole squared times 1. So these three terms are exactly like terms, so we can finally say that partial with respect to x plus partial with respect to y plus partial with respect to z squared operating on the function phi, that's equals to negative 9 divided by x plus y plus z whole square. So this is the value of the given expression.